Hello, amazing Integrated 1 students. We're going to be going over a review that's preparing us for the Chapter 10 upcoming test. Something to keep in mind is we do have to know how to use a graphing calculator. So if you don't have one out right now, please pull that out. The main idea is we're looking for the stat button on our graphing calculator. Once we locate the stat button, which I'm using an app for right now, stat, we do need to enter the numbers that we have on our given lists. And one of the main things we have to do is we have to be able to calculate the 5-number summary, as well as other important numbers that we can either figure out using our calculator, or
here's what I found,
or by looking at our list. So it says here to calculate the 5-number summary, we need to use the stat button, which I pointed out is right there on our graphing calculators, and enter the list of numbers. After we enter the list of numbers, we need to press the stat button again, go to calc, and choose one variable statistics. That's very important. You will see lots of numbers there in a chart to help you understand what some of these numbers mean. Once you understand the list, find the value of each term. So, a couple of important things. We have x bar, this is the mean, aka the average. We have Q1, Q3. We have standard deviation, which uses this symbol in your calculator. We have MED, which is the median. And of course, we have the minimum and the maximum. If you want to find the range, you're going to need to do the maximum minus the minimum. And if you're trying to find the IQR, you're going to have to use the quartile 3 minus the quartile 1, which is the range of the quartile. So that takes us to our very first problem, which is number 1. Number 1. The speeds in miles per hour of 21 motorists ticketed during the one day on a 5-mile stretch of highway are listed below. These numbers. So we need to enter these numbers in our graphing calculator. So what we do is we press stat, we edit, and we enter those numbers into our list. I'm just going to double check that I have every number here. Yes, I do. So now we need to go ahead and find the 5-number summary and use it to make a box plot. Okay, so what I will do now is I will press stat, I'll go right to calc, and one variable statistics. I'll press enter, giving me a very important list. So I'm going to go ahead and find these different things since I do need the 5-number summary. The minimum is going to be 70, which is the lowest number on this list. Measures the central tendency, which is the mean, median, and mode. The mean is going to be the first number. X bar in our calculator shows up as 78.7619. I'm going to go ahead and round that to 78.8. One decimal place is fine for speed. The median, again, is the same number shown up on our list as MED, which is 75. And then the mode is which number is most showed. Most showed number. So which number on this list shows up the most? Let's see. We have 74, 74, 74. We have 75. Couple times, but it looks like on this list the number that shows up the most is going to be 74. I'm going to double check. But yeah, the number that does show up the most is going to be the number 74, which completes number 1. Okay, let's move on to number 2. Using your 5-number summary, draw a box plot given the numbers shown in problem number 1. So using these 5 numbers, I do need to create a box plot. So I'm going to start with my lowest number, 70. I'll put a dot there. My highest number is 89. I'll put a dot there. Now I do need to create numbers in between here, so I'm going to go ahead and just label this as 70, 75, 80, 85, around there. It doesn't have to be so perfect, but as best as I can if there's no number line given to us. So now I'm going to go ahead and label. We have our quartile 1 at 73.5, so about there. Our median is going to be 75. Our quartile 3 is going to be 85. And I'm going to add a box around Q1 and Q3. I'll put another line or line segment on our median, and I'll create 2 whiskers for our minimum and maximum. Again, remembering this dot right here is the median. So as you can see, these numbers are, or the numbers showing on our box and whisker plot are pretty spread out, but there is a very low median. Okay, let's move on to number 3. For number 3, it's important to know that there are both open and also closed circles. Open would be greater than or less than. Closed would be greater than or equal to or less than or equal to. But keep in mind, when we're dealing with a coordinate plane, we're going to be talking about open as dotted lines, while closed would be solid lines. So for our first inequality, I'm going to go ahead and create a coordinate plane here. For our first inequality, it looks like our slope is negative 2/3, and our y-intercept is positive 1. So I'm going to put a dot at positive 1, and I'm going to go down 2 over 3. Down 2 over 3, because the slope is negative 2/3. I'm going to do this going backwards. I'm going to go up to left 3, up to left 3, creating a line. Now, why am I not doing a whole solid line? Remember, what type of equation is this one, right? It's going to be or inequality. This is going to be y is less than negative 2/3 x plus 1. So not only do I need to have a dotted or dashed line, I also need to shade below since it's less than. So I'm going to shade everything below this line. Okay, next up, I'm going to go ahead and graph the second equation. For the second equation, it's going to be a y-intercept at negative 3. So find negative 1, negative 2, negative 3. And I do have to go up 5 over 2. So 1, 2, 3, 4, 5 over 2. Up 5 over 2. I'll do the same going backwards. 1, 2, 3, 4, 5 over 2. And I'm going to create a solid line. Again, the equation or inequality that I just graphed was y is greater than or equal to 5 over 2x minus 3. So this is going to be a solid line, and it's also going to be shaded above since it's greater than. So above this line is going to look like this, above the line there. So now we know that our solution area is where they intersect. So I can go ahead and grab a pencil at this point, or perhaps a different way to shade. And this right here would include all of our solutions to the system of equations. So everything in this region is a solution. Okay, a great thing to do is also to test 0, 0. 0, 0 is 0, 0 a solution to this one? If you plug in 0 for x, 0 for y, would it be true? Is 0 less than 1? Yep. Is 0 greater than -3? Yes. So if you plug in 0 or substitute 0, it's a great way to check that this is a solution, and it is. Okay, now moving on to number 4. We have a 5-number summary shown on this box plot. Okay, just like number 2, where we created our box plot, we are given one and we have to label which things are which. So minimum is going to be the smallest number. Looks like it's 2. The maximum is the biggest number. Looks like it's going to be 10. Oh, quick question. What's the range? Right, how wide apart are these numbers? They're 1, 2, 3, 4, 5, 6, 7, 8. You can see they're 8 apart. Otherwise, just do 10 minus 2, which is 8. Okay, next up is going to be labeling the median. The median appears to be 6, while quartile 1 appears to be 3, and quartile 3 appears to be 8. Now, our last question here that I could add is, what is the IQR? Basically, what's the range of the quartiles? What's the interquartile range? How far apart are these two numbers? 3 and 8. We can count 1, 2, 3, 4, 5. They're 5 apart. Otherwise, just do 8 minus 3 is 5. So interquartile range, remember interquartile range is pretty much always less than the full range. So I'll label this here. The range is how far are apart are the maximum and the minimum, while the IQR is going to be how far apart are the quartiles, the interquartile range. Okay, let's move on. Number 9. Melissa is looking for the perfect girlfriend. She claims that of the girls at her college, 41% are smart, 32% are funny, and 20% are smart, both smart and funny. Be sure to label and calculate the percents who are neither. So for this one, I'm going to go ahead and choose a two-way table because the two-way table is the one that is most popular for these tests. So what I'm going to do is I'm going to label according to her survey, Melissa's survey. We're going to be talking about whether they are smart or funny. So according to this, we just have to say whether they're yes to smart, no to smart, yes to funny, no to funny. So according to this one right here, it says out of the 100% of people that she knows or is looking at potential partners or friends, girlfriend, she claims that of the girls at her college, 41% are smart. So 41% are smart. Yes to being smart. 32% are funny. Yes to being funny. And 20% are both smart and funny. 20% are both smart and funny. So we can kind of label that as yes, yes. Now, is it possible to figure out the rest of the diagram? Of course, if you chose to create a Venn diagram, you would have been looking at smart, funny, and putting the numbers in there. And 20% would be those who are both smart and funny. But what about those who are just smart and not funny, or just funny and not smart? So we're going to complete this table, and let's check back and see if we got the same numbers. So far I did 100 minus 32, and I got 68. A 100 minus 41.
The answer is 59.
We get 59. 41 minus 20. 41 minus 20.
It's 21.
This would have to be 21. And now if this is 21, and these add up to 68, I can do 68 minus 21.
The answer is 47.
And 59 minus 47.
The answer is 12.
Or I could have done 32 minus 20, and that gives us all of our answers. So that calculates every single person. A great way to check if we did this correctly is make sure that everything in here adds up to 100%. 20 plus 21 plus 12 plus 47.
The answer is 100.
So that checks off. Okay, let's move on to number 10. The box plots below summarize calculus scores in two different regions. Which region had the lowest high score? So the lowest high score is going to be this guy right here. Which one's lower? Go ahead and say Edmonton. Approximately what was their score? If I look down at that, it looks like it's about 90. I can say go ahead and say 90%. Which region had the highest median score? The highest median score. So the highest median score is this right there, which they appear to match. So I would say neither. They both have an equal median score of 75. Which region had the smallest IQR? So if we're looking at IQR, we're looking at how far apart are Q1 from Q3. How far apart? How wide is the box? So which region had the smallest IQR? We can go ahead and say that Edmonton had a smaller IQR. Approximately what is it? Let's go ahead and subtract Q3 from Q1. Q3 appears to be about 80. Q1 appears to be about 60. So if we do 80 minus 60, we get that the IQR is 20. 20%. And now the next one and final question here is which region had the highest range? So the widest range. The range is going to be how far apart are the minimum from the maximum. So I would definitely say for this one that the highest range would be Calgary. Calgary had a range of about, let's just say 100 is their maximum, 40 is their minimum. So they had a range of 60%, 100 minus 40, 60%, while the other school or region had a range of a lot less range. So that finishes up number 10. So I just realized I'm kind of working a little bit backwards here. I did number 1, 2, 3, 4, and I skipped number 5, 6, 7, and 8. So we're going to go ahead and jump from this and make our way back to numbers 5, 6, 7, and 8. Okay, so for number 5, it says 300 adults in Castro Valley were surveyed. So a total of 300 were surveyed. About which vehicle they'd choose. 60 of which identified as tall. 156 said they would choose an SUV. So choosing an SUV is in this row. 156 said they would choose an SUV. And also, 45 tall people said they would choose a sports car. So where does 45 tall people choose a sports car? Where would that be? Yeah, that would be right here. That is where tall crosses with sports car. It says that there are 45 of them. So now we need to complete the rest of our table based on what we are given. So I'm going to quickly go ahead and fill out the rest of the table. You can pause the video here and let's check back whether we got the same numbers in our table. Okay, let's check if we have the same numbers in our table. Just by doing subtraction, we can fill out all the missing numbers in our table. So I am only missing one number, the number of people who are not tall and don't want sports cars. So I'm going to ask, how do we fill out this number? What would you do to fill out this missing number? Would you rather use the column to figure it out? Or would you rather use the row to fill it out? Either way works, but yeah, let's go ahead and subtract 144 minus 45.
The answer is 99.
Or we could have done 240 minus 141.
The answer is 99.
So it gives us those missing numbers. Okay, now based on these numbers, we need to go ahead and answer a few problems. It says, how many people identified as tall and would choose an SUV? Tall and SUV, looks like there's 15 people. Where tall crosses SUV. How many people were not tall or would choose a sports car? So this is actually a tricky one. There's multiple ways to figure it out, but not tall includes these people. Or, which is either, they would choose a sports car. So 45 people would choose a sports car, but also 99 people would choose a sports car. So with this, we have three options of people that either are not tall or they would choose a sports car. So what I'm going to do is I'm going to just add up those three numbers. Now, why would I not count these two? Why would I not count the 99 twice? Right? 99 is not only part of the not tall group, it's also part of the sports cars. So if you are using the totals, which you could say 240 are not tall, or 144 choose a sports car. What would actually happen if you added those two up? What's 240 plus 144?
That would be 384.
You would get 384. How many people are there actually? Right? There's only 300 people. So that means if you are going to use the totals, you must subtract 99. You cannot count 99 people twice. So again, the first way is just to add up the three numbers. The second way is if you're going to use the totals, be sure that you not only add them up, but you also have to subtract 99. So let's see what that number would be. 141 plus 99 plus 45.
It's 285.
Now doing it the second way, with the totals, 240 plus 144 minus 99.
The answer is 285.
We get the same answer of 285. Now here's the weird thing. You can use the complement rule, which means, look, the only people that we're not including are the tall people who enjoy SUVs. So if we took 300 and subtracted 15, what's 300 minus 15?
It's 285.
So these three numbers, there's many ways to figure out that the answer is 285. Now 285 out of what? 300. Let's divide those to get what percent of people would choose a sports car or are not tall. I'm actually writing in the wrong space, so let me go ahead and fix this. 285 out of 300. 285 divided by 300.
The answer is 0.95.
So it appears to be exactly 95%. Okay, now I did write in the wrong place, so let me go ahead and cross this off. Next question. What's the probability that a randomly chosen adult would choose a sports car? Now, how many people choose sports cars? 144. 144 people choose a sports car out of 300. Let's divide those two numbers. 144 divided by 300.
The answer is 0.48.
0.48, which is 48%. Okay, now letter D. What is the probability that a randomly chosen not tall adult would choose a sports car? Okay, for this one, we're not given 300. We're given less people. How many people are not tall? Right? We're only given 240 people. Now, of those 240 people that are not tall, how many would choose a sports car? 99. So 99 out of 240 would choose a sports car. What is 99 divided by 240?
The answer is 0.4125.
It might be exactly 0.4125. Let me just go ahead and check with a calculator as well. 99 divided by 240 is exactly 0.4125, which is 41.25%. Okay, let's move on to number 6. So for this one, we're going to have to identify the triangle congruent statement, if any. Here's some words to remember: vertical angles, shared side or reflexive property, and then the 5 congruent statements. So for this first one, we do have vertical angles that we can add to the diagram, allowing us to notice that the answer is an angle given, a side angle, an angle given, a side given, and a vertical angle, while the second angle is a vertical angle, a side given, and an angle. So what does that spell? ASA. Okay, letter B. We're given a right triangle labeling A for angle and S for side. We can look around the triangle that it does spell angle, angle, side. Next up, letter C. We're going to go ahead and add the shared side. the reflexive property. That gives us, on one triangle, gives us SAS. And on the second triangle, it gives us SAS with the shared side. So the answer here is SAS. Now letter D. This one spells, let's see what it spells. We have A for angle right there, S for side, and another S for side. We can check the second one as well. We have A for angle, S for side, S for the other side. So at this point, we can see that it is the donkey one. So we can go ahead and say that it's not necessarily congruent. ASS is not one of the 5 congruent statements. Okay, let's finish off with number 8. Make a table and graph the following exponential at least 5 points on both scale appropriately. So for this one, we have to remember that it's y equals a times b to the x, where a is our starting value, or y-intercept, and b is our multiplier, or our growth rate. So according to this equation, we have 2 is our starting value, and 1/3 is our multiplier, or growth rate. So I'm going to go ahead and perhaps label this as -1, 0, 1, 2, 3, just some numbers that are in a row or adjacent to each other. So that gives us a couple of things. The starting value is always 0, something. So according to this, the starting value is 0, 2, since it is our starting value. Our multiplier is 1/3, so I need to multiply by 1/3. What is 2 times 1/3? What is 2 times 1/3?
It's approximately 0.6666.
So that gives us 0.6666, approximate. Those numbers go on forever. And if I keep multiplying, what is 0.6666 times 1/3?
It's approximately 0.2221.
0.2222. And if we multiply that by 1/3, what is 0.222222 times 1/3?
It's approximately 0.07407.
Okay, now we can work backwards by dividing by 1/3. What is 2 divided by 1/3?
It's 6.
So we get some more important numbers. Again, something to keep in mind with these ones is we can think about it as going down as dividing by 3, while if we're going up, it's multiplying by 3. So we could get even bigger numbers going up and even smaller and smaller numbers going down. So I'm going to go ahead and just label my x-axis around here, my y-axis around here. I'm going to label my starting value at 2. We have -1, 6. 1, 2, 3, 4, 5, 6. We have 1, 0, 67 approximately, which is right there. And we have 2, 0.222. 3, 0.07. These numbers are getting so small so quickly, but it's never going to reach 0. So the numbers are going to be, we can define this as decay, and it's also exponential decay. Stat button is very important. We went over number 1, which was data and stats. Number 2, which was a box plot. Number 3, which is systems of linear inequalities. Number 4, which is another box plot problem. We went over number 5, which is probability. Number 6, which is preparing us for the final, which is triangle congruence. Which is probability questions. Number 8, which is exponential growth or decay. Number 9, Venn diagrams and two-way tables. Remember to focus mainly on the two-way tables. And number 10, a couple of box plot problems. That wraps it up for today. Hope you have a great rest of your day.